Welcome. This video is going to take a closer look at properties of compounds that contain polar molecules or polar bonds forming polar molecules. So one of those properties we want to look at is solubility. And solubility is how well one thing dissolves in another. And a common example is in our day-to-day lives we often have solids dissolved in a liquid, like when you mix up, a sports drink or other things. We do that often. But it can be a gas dissolved in a liquid or a liquid dissolved in a liquid. There's a lot of possibilities. But the general rule for solubility is that like dissolves like. And that means polar stuff will dissolve polar stuff and nonpolar stuff will dissolve other nonpolar stuff. But polar and nonpolar, they don't dissolve or mix so well. So when you have something like oil and water and they won't mix, that's a hint to you that one is polar and one is nonpolar. Polar also dissolves ionic because ionic substances and polar substances both have dipoles or charged areas, a positive area and a negative area. So really when you think about like dissolves like, you could think that charged dissolves charged, non-charged dissolves non-charged. So polar and ionic can dissolve each other, nonpolar and nonpolar can dissolve. So here's an example. Water dissolves sugar and salt easily, but water will not dissolve oil even with a lot of shaking or stirring. So what can we conclude about this? Well, we know that water is polar. Remember, it's a bent molecule with polar bonds on it. So that means sugar must be polar ionic and salt also must be polar ionic. And in reality, sugar is polar and salt is ionic, whereas oil is nonpolar. So that's why sugar and salt can easily dissolve in water, and oil, shake it as much as you want, it just won't dissolve in water. Which brings me to some other questions here. Why won't just hot water get oil out of your clothes, and what must be true about the polarity of a waterproof pen? So think about this for a minute. Water, even when it's hot, is still polar. Oil, regardless of whether it's hot or cold, is a nonpolar substance. So no matter how hot your water is, it's still not going to do a very good job of getting the oil out until you use some kind of detergent that has both polar and nonpolar properties or ends to it. As far as the second question, what must be true about the polarity of a waterproof pen? Since water is polar, then waterproof would imply it should be nonpolar. So that's why when you get ink on something, again, you need to use some kind of nonpolar solvent, spray and wash or something to get that pen out, because water itself is not going to do a good job for you. Another property to talk about with covalent bonds in general and polar and nonpolar molecules is the strength of those bonds. Covalent bonds in general are much weaker than either ionic or metallic bonds. But then within covalent bonds, nonpolar bonds are going to have the weakest forces of all. Well, the more polar a bond gets, the stronger that bond becomes, and it gets closer to being more like a metallic or ionic bond. So we really have 4 different kinds of chemical bonds that can hold compounds together. The strongest chemical bond are ionic bonds. The weakest are nonpolar or pure covalent bonds. And in between then are metallic bonds, which tend to be stronger than polar bonds, which are stronger than nonpolar bonds. General properties of covalent compounds: because they have weaker bonds than ionic or metallic bonds, they tend to have pretty low melting and boiling points. In fact, many covalently bonded substances are either liquids or gases at room temperature. If they're not a gas at room temperature, they tend to vaporize or boil easily if they're a liquid. Or if they're a solid, they tend to be soft solids like wax or butter. And in fact, oftentimes they'll melt in your hands. That's all they need for heat to get warmed up. And because they're soft, that means that they're not brittle like ionic compounds are. They're poor conductors. I didn't include this on here, but they tend to be poor conductors as liquids or solids. And unlike gases or unlike metals, they're not going to be good conductors of electricity, and they're not going to be very malleable or ductile.